Assalamualaikum to Madam Asha. Today our group would like to present to you our assignment topic tunnel. First, we will look at the introduction of tunnel. The definition of tunnel is a long passage under or through the ground built as an alternative road when the routes are separated by large obstacles such as mountain, hill and river. Tunnel can be in several categories, depends on the situation and type of tunnel to be constructed. The categories are traffic tunnel, hydropower tunnel and public utility tunnel. The public utility tunnel such as the railway station and built in the underground.
Now, let's move on to the types of tunnel based on its functionality. So the first one, we have transportation tunnel. It is basically a tunnel that provides passage for any type of transportation to pass by through it, which include cars and trains. Transportation tunnel usually been constructed on a high density area and it helps reduce the traffic congestion and provide alternative and also a faster route. Complete system is a must for transportation tunnel. The system include like ventilation system, lighting system, fire life safety system, communication system, and etc. The second one, we have mine tunnel. Mine tunnel function as an easy passage for laborers to access mineral and metal deposits located deep inside the earth. Unlike transportation tunnel, mine tunnel doesn't require a proper finishing since it is a non-aesthetic tunnel. As long as the tunnel can fully function and provide a safe access for the workers, the tunnel is good to go. Lastly, we have public work tunnel. Public work tunnel function in locating pipelines underneath the surface of earth. For example, the pipeline that can be located under the surface of the earth is sewer pipe, gas pipe, and many more. Now, let's have a look at the different shape of tunnel that existed. So there are few common shape of tunnel which are circular tunnel, rectangular tunnel, elliptical or egg-shaped tunnel, and lastly a horseshoe-shaped tunnel. Okay, each and every shape of the mentioned tunnel has their own suitability in terms of product or item to be carried through. For example, egg-shaped or elliptical tunnel much suitable to carry pipelines rather than to be made as a transportation tunnel. Contrary with horseshoe-shaped tunnel, it is much more suitable to be used as a transportation tunnel like trains and subways. Now, moving on to the components of tunnel. So basically, in every shape of tunnel, there are some jargons, quite a lot of jargons that should be understood. But let me give a few examples. For instance, like the uppermost part of tunnel, we usually call it crown. The bottom part of tunnel, we usually call it invert. Meanwhile, lining is the outer part of tunnel which serve the functions of maintaining this tunnel structure. So, next, this is an example of cross-section of a tunnel road. We can see few elements like tunnel lining, the travel lanes, the drains, tunnel ventilation fans at the ceiling, and many more. Next, this is just an overview on what the road tunnel is supposed to look like. Usually for transportation tunnel, it should be constructed with a complete system. The tunnel should have road furnitures and also road signages. Here we can see the tunnel being constructed complete with lane control sign, suggested speed limit, CCTV, emergency exit, emergency phone, and many more. So a complete constructed tunnel will simultaneously provide safety to the consumer. Alright, moving on to the next part, which is design consideration. In order to construct a tunnel, there are so many things need to be considered beforehand. So the first one, we have tunnel ventilation system. Since tunnel is located in an enclosed area, a ventilation system is a must to ensure a good flow of fresh air across the tunnel. The placement of the tunnel ventilation duct is also crucial to be taken into consideration. So there are two types of tunnel ventilation system, which are longitudinal ventilation system and also transverse ventilation system. Second consideration will be tunnel lining. As mentioned before, tunnel lining function in maintaining the structure of a tunnel, and there are different types of tunnel lining based on material used. So we have in situ concrete lining, sprayed concrete lining, and segmental lining. The third consideration will be tunnel lighting. Tunnel lighting mainly function to provide safety to the consumer due to a very dark area inside the tunnel. Nothing special, but tunnel lighting is the most crucial part in tunnel construction. Lastly is tunnel maintenance. Maintenance is a huge consideration to ensure a longer lifespan for that particular tunnel. All systems need to be maintained regularly, and the system include ventilation, lighting, electrical, and not just tunnel system. It should include finishes. So it should be also well maintained to provide a safety for user. Next, moving on to the material to be used for tunnel lining. As what I mentioned before, types of tunnel lining to be used is depending on the material. So therefore, here are some of the examples on material that usually been used as tunnel lining. So the first one we have brickwork, blockwork, or masonry. So these material often been used in early era of tunnel construction, and nowadays this material has been outdated. So the second one we have concrete. Concrete has been widely used in construction industry due to the advantages it has. For instance, like a strong structural integrity, can be cast on site, can be prefabricated, can be mechanized, like lessened amount of manpower needed. So it's very flexible, but also concrete has a disadvantages, like it cannot hold the load right away. I mean, it needs to be molded and cured until it reaches the predetermined strength. Then only it can function. So there are few types of concrete lining, which is in situ concrete lining, flake concrete lining, reinforced concrete lining, and sprayed concrete lining. Lastly, for material that can be used to construct tunnel lining is preformed segmental. So preformed segmental can be made out of cast iron, steel, or reinforced concrete. In preformed segmental, it is important to pay attention on how to connect between segments and what product that can be used to seal joints and to fill voids.
Methods of tunnel constructions. Firstly, a cut and cover tunnel is a method that advocates excavating an open trench. Secondly, drill and blast. This tunneling method involves the use of explosive. Drilling rigs are used to drill blast holes on the proposed tunnel surface. Next, an immersed tube is a kind of underwater tunnel composed of segments constructed elsewhere and floated to the tunnel site to be sunk into place and then linked together. Jack-box tunneling is a unique method for building shallow rectangular road tunnel beneath critical infrastructure. Next, bore tunneling is a method of using a tunnel boring machine, which often used for excavating long tunnels. Lastly, the sequential excavation method, or also known as the New Australian tunneling method, is a concept based on understanding the ground behavior in response to the development of underground aperture. Tunnel construction process, in which the process of construction will be carried by sequence. Firstly, in profile marking, it is necessary to create the desired form. Phase drilling. After the profile has been marked, the working phase is drilled using 2 hydraulic boom jumbos. Charging and blasting, expert personnel perform the manual charging of holes. Blasting pattern. On the tunnel phase, holes are drilled in a variety of patterns. Defuming. Ventilation fans defume the explosion area. Scaling is required to offer an accurate dark profile for the installation of lattice girder. Marking is the process of putting rock, dirt, or any other excavated material into a truck. Geological phase mapping is the process of examining the types and number of joints. Phase sealing shotcrete is to avoid any accident that may occur. Lattice girder erection offer initial support and give the tunnel a defined form. Four-poling refer to the procedure of placing 4 poles. 3D monitoring target installation used to determine whether the support system is adequate for the specific rock type. Initial leaning with shotcrete for supporting and building subterranean excavation. Lastly, rock bolting and grouting. Rock bolts are inserted to stitch the shotcrete to the rock tightly.
For the case study, our group chose Stormwater Management and Road Tunnel, SMART, which is located at Kuala Lumpur. The project background of SMART. SMART purpose is to overcome the flood problems that frequently happen from Klang River during the monsoon season. SMART project was considered as a mega project. The location of SMART made the construction harder as it located at extreme ground condition, which is the cast ground. Before the construction begins, it needed ground investigations. Several areas were being investigated by vertical boreholes to identify the ground condition. Boreholes method used to represent the effective area for the calculated cast percentage. After all the investigation process were done, the construction of SMART began. The SMART project was commenced in December 2003 and completed in June 2007. SMART consists of a 3 km double-deck motorway within the stormwater tunnel with 9.7 km. The floodwater collected from SMART is discharged at Sungai Kelang or Sungai Ampang. The operations of SMART can be divided into 4 modes. The first mode is when normal conditions, no storm or floodwater, which is the tunnel will be open for traffic. And the second mode is moderate rainfalls. The flow rate will be 70 to 150 meter cube per second. The tunnel is still open for traffic. And the third mode is when the major storm happen and the flow rate is 150 meter cube per second or more, and the traffic will be closed for a while within 1 to 2 hours. And the fourth mode, when the heavy rainstorm prolongs, the fourth mode will be activated after 1 to 2 hours. The third mode is activated and the traffic is remain closed. It will be reopened after 4 days of the closure. Then the parties involved during the construction of SMART project, the employer is the Malaysian Highway Authority and Department of Irrigation and Drainage Malaysia. The employer is basically the government. And the main contractors, they have 2 main contractors, which are Malaysian Mining Corporation, MMC Berhad, and Gamuda Berhad. Both of these contractors are formed by joint venture. And the subcontractor appointed by the main contractors are Comba Telecom System Holdings Limited and SMEC Sinar Berhad. For the Comba Telecom, their service is supply and install and distributed antenna system for high-speed wireless communication across the SMART. Meanwhile, for the SMEC Sinar Berhad, they are required to design, review of tunnel lining and cut and cover tunnels, review of tunneling related construction impacts, monitor the environment surrounding the SMART project. Materials used for SMART project. First, bentonite. What is bentonite? Bentonite is a material made from montmorillonite clay which has thiotropic properties. Bentonite is used for the ground settlement for the SMART project, as the project located at extreme ground condition which is scarce ground. And how does bentonite works? The functions of the bentonite is when it coagulates or becomes solid, it will form a gel which is highly resistant to water, and when the bentonite mixes with certain additives like Portland, cement or soluble silicate, the barrier form will be permanent, which can be referred on the figure at the right side. It shows that the cavity along the pathway of the SMART construction, and the second figure is how the bentonite filled the cavities, which is form the barrier for in the soil. How much bentonites are used for the SMART project? The bentonites are used at the average of 9,300 tons for the whole project, and 17.82 tons each day were used during the construction process. The average consumption of bentonite for excavated material was 12 kg per meter cube. And the figure at the bottom is a short video of how the bentonite is being put in the cavities and how the bentonite working in the TBM. The second material used for SMART project is precast concrete. SMART project is built with precast concrete segments. The concrete segments are then assembled to form rings. Each ring consists of 9 concrete segments including the keystone. Total rings in completing the SMART projects are 3,100. The 3,100 rings are equivalent to 27,900 precast concrete segments. The video at the bottom shows that how the rings are formed from segments. The segments are jointed by specific jointing method to form rings, and then each rings will be jointed together to form a tunnel.
The next one, tunneling method. The first one, slurry mid-shield tunnel boring machine, TBM. The 13.25 meter diameter smart tunnel was constructed by using the tunneling method, the slurry mixed-shield tunnel boring machine (TBM), also known as slurry TBM. TBM will be carrying out 95% of the entire tunneling activity. The remaining 5% will be done by using cut and cover method. For Smart, the chosen brand is Herinath from Germany. The Smart project used two TBMs. The first one named TBM Tua for the north side, and the second one is TBM Gemilang for the south side. TBM Tua and TBM Gemilang began the Smart project at the JKR field area at Jalan Chan So Lim. Two slurry shield TBMs began mining in the same area and made breakthrough in different locations. The first mission, TBM Tua, proceed north along Jalan Tun Razak and Jalan Taman Desa Pandan before arriving at the pond near Gleneagles Hospital in Ampang, Kampung Berembang Pond. And then while for the TBM Gemilang, the second machine proceeded south beneath Jalan Chan So Lim and the KL Seremban Highway, passing near to the Sungai Bersih airfield until coming to a stop at the existing pond in Taman Desa. Next, the components of slurry mixed-shield tunnel boring machine (TBM). Generally, the slurry mixed-shield tunnel boring machine (TBM) consists of four main parts. The first part, it consists of rotary cutter head with tungsten peak bits, which it is made for excavation of soil, and then these cutters for excavation of rock. Moving on to the second part, bulkhead, positioned behind the rotary cutter head. It is for during the tunnel excavation, a pressurized bentonite slurry barrier is formed to provide stability. The third part, hydraulic ramps. It is to move the machine ahead while keeping the tunnel in proper alignment. Next, fourth, tunnel lining erector, to install the precast concrete lining of the tunnel. Two bogies on rail house electrical, slurry pumping, ventilation and cable and pipe equipment, as well as other pieces that complement the main parts. Next, the advantages of using tunnel boring machine, TBM. The first one, greater production rate than the drill and blast method and reduced labor force. The second one, TBM is safer since a shield protects the working area and no explosive are used. The third one, there is a little disruption to the surrounding rock mass. The fourth one, it provides a better level on precision and allows the entire procedure to be finished in short period. The fifth, it is capable of boring sand to hard rock and is designed to function in a variety of ground conditions. And the last one, it is suited for tunnel construction in high traffic areas, densely populated and difficult areas such as high water table areas. Next, cut and cover method. The cut and cover approach was one of the first tunneling technique utilized across the world. This technology was quite effective until the TBM machine was invented, which revolutionized the tunneling industry. This method is based on digging the ground along the tunnel path, building the tunnel, then burying it by backfilling the root with earth and compaction materials such as sand or quarry dust. To keep the trench from collapsing, strong supporting beam must be installed. However, this strategy is ineffective in densely populated metropolitan regions with high-rise towers. Only shallow trenches are acceptable for the cut and cover procedure. Hence, this becomes the main reason why the cut and cover is not chosen as the main tunneling method for smart construction project. Due to only one source of a picture of the cut and cover method for the smart project, it is assumed that this project used the top-down construction method. Next, construction process. So we're going to talk about the slurry mixed-shield tunnel boring machine (TBM) first. These are the schematic construction sequence for TBM. For the whole construction process of TBM. The first one, we have launching shaft. Second, assemble TBM. Third, initial drive mode configuration. Fourth, mark out. Fifth, segment into shaft. Sixth, close of launching shaft upon completion. Noted that during the 1 to start 6 steps on the working yard, there will be a fabrication of segments, setting out gantries, and slurry treatment facilities, and etc. Moving on to the next one. 7. Boring or excavation process starts at the advanced rate. 8. Assembly of lining. 9. Backfilling grouting. 10. Receiving shaft. 11. Disassemble TBM. And last but not least, close of receiving shaft upon completion. This is the image of the TBM construction process. Moving on to the details on how TBM is passing through the soil. Firstly, the cutter head, which employ these cutters and sit at the very front of the TBM, does the majority of the hard work by rotating and digging away at the dirt to allow the machine to go forward, and is made up of hundreds of steel blades that chip away at the soil ahead as it spins. The concrete panel are put directly behind the shield, forming the tunnel's outer layers. The panels are lifted up and put in a place by revolving vacuum-driven lift as the cutter head progresses. And then we can see the construction for the road tunnel inside the smart tunnel. Next, second method is smart tunnel, cut and covered method, which comprise for 5% of smart construction project. The first one, we have installing of retaining wall. Second, excavation and installing of steel struts. Third, construction of underground structure. And fourth, construction of underground structure. Fifth, construction of underground structure. Sixth, backfilling and reinstatement. And these are the general video for the cut and cover method. Moving on to the next one, problems and solving method during the smart construction. The first one, condition of the soil. In Kuala Lumpur, there are three types of ground condition, which are hard granite rock, sulfur mixed geology known as the Canning Hill Formation, and limestone parts. From 2004 to 2007, two huge Harineth mixed shields were used to excavate the smart tunnel. The drive was a huge success, but the geology shows its flaws. The smart tunnel path passed through the karstified Kuala Lumpur limestone with a high level of groundwater for approximately 90% of its length. Suspension leaks on the surface and losses into the ground were often caused by the fissures and cracks. Hence, the slurry mixed shield TBM was chosen for tunneling due to the nature of the soil structure. Next, cavities in soil. When unforeseen cavities are filled with washed-in dirt, the slurry mixed shield TBM can generally interact with them, preventing huge amount of slurry loss to the karst system. The low-density bentonite slurry base face support on the SMART project did the work while traversing minor cracks and filled cavities encountered into the karst. Next, excavation. Due to the possibility of settlements, the presence of karstic limestone and ground cavities, TBM excavation would be difficult. 4 technological precautions and 5 practical countermeasures are provided below to overcome potential hazard and mitigate bentonite loss. The first one, technological precaution. The first one, we are going to use the MOCA model. Next, second one is by using specifying proper TBM parameters for tunneling through various types of ground condition. The third one is extensive site studies using geophysical techniques, borehole, piezometers and other instruments. The fourth one, real-time surface settlement monitoring helps prevent surface unsettlement. And then moving on to the practical precaution. The first one is by using TBM probe drilling. Second, differing color contours. And the third one, slurry composition and volume are adjusted. And the fourth one, drilling and grouting from the ground surface ahead of the TBM in sensitive zones. And then last but not least, grouting. Next, position of smart tunnel and TBM. It is important for the smart tunnel to be placed in the right position as it is able to disturb the surface of the land or any area. Hence, JPS Malaysia is responsible to solve the problem by preparing the right of way (ROW). The term ROW refers to the maximum amount of work that can be done. The goals of the ROW are to find the optimal tunnel alignment, to ensure that this project is on government land, and to prevent any obstacle that could disrupt smart development. As you can see in the slide, on the left side is smart tunnel before the ROW and the right side is smart tunnel after ROW. It demonstrates that the tunnel is on government property and does not cross the Kerayong River. To ensure the TBM installation is correct and to guide the starting of TBM movement, all observations were analysed using StarNet software. TBM machine was positioned on the cradle. If the TBM was in a fixed location, the TBM installation was correct and it was ready to begin the mining process. Next, Vibration and underground soil disturbance. Vibration from the tunnel's construction and drilling is a common factor. One of the major difficulties in the underground tunnels may cause some vibration of existing buildings. Hence, in this case of the Smart Tunnel project, the tunnel alignment is designed to cause the least amount of vibration to the surrounding area. TBM machines, for example, are quite valuable since they have little impact on the soil geology and groundwater sources. Lastly, congested area. As stated previously, due to the crowded and lack of spaces in the Kuala Lumpur area, hence the SMART project need to use 2 slurry shield TBMs. The Tuah and Gemilang TBM need to start the mining process in the same area, which GKR field area in Jalan Chan Solin, and the breakthrough at the different places. TBM Tuah headed to the north, which at Kampung Berembang Pond, and the TBM Gemilang, which headed to the south, will end in the existing pond in Taman Desa. Even though the Smart Tunnel is built in a congested place, its strength has been examined and the tunnel will not be impacted by earthquake or tremors because it was built below and in a circular shape that can bear forces from any direction. In conclusion, tunnels are constructed under high mountains and sea coming across the way. Both are necessary as per requirements. It depends on all kind of things like local planning, ground condition, future planning of the surrounding area including use and ground levels, and usage of the waterways below. The conventional tunneling method is a cyclical process of tunnel construction that involves excavation by drilling and blasting or by mechanical excavators. Diverse tunnels have been built and are now running for various purposes across the world, ranging from the traditional drill and blast approach to the more modern tunnel boring machine. The progress of tunneling technology has also benefited Malaysia's construction sector. The Malaysia government has built a variety of multifunctional tunnels to meet the demands of the general population. The Smart Tunnel in downtown Kuala Lumpur is one of them, serving not only as a traffic tunnel but also as a flood prevention measure. That's all from us. Thank you.